the most recent, wait, why am I blanking on the name? Starship?
Link? Starship? Like the recent SpaceX trials?
The most recent Starship launches.
Yeah.
Right? If you watch the video, which I totally recommend, everyone goes and watches the video of the trials, that they were just testing like landing, right?
They were basically just testing the whole situation where, okay, let's simulate it like if it's on Mars.
High altitude.
Yeah, like what's going to happen.
Landing.
Basically, like they were simulating like, okay, let's say they're now entering the Martian atmosphere or the Earth atmosphere. They're basically simply trying to land it and to see how well their telemetry works. I believe that was their main mission, yeah.
And so you'll actually notice in the video that the Starship goes horizontal once it reaches the peak height in the flight. And that is actually because of air resistance, right? It goes horizontal so that just the geometry of the ship slows it down. Slows it down.
Slows. Straight up slows. Okay. What do you say what slows is? What does that even mean? What are you saying, man?
It slows it down.
Straight up slows.
So that it doesn't have to use any extra fuel than it would need. If it were to fall vertically, it would need to use more fuel to slow it down. And, obviously, you want to save on costs. You want to take advantage of the fact that we have an atmosphere and say, if we just go horizontal, we'll slow down. We'll actually be able to like steer towards the landing because there are like some fins on it, right? So, of course, some smart people over at SpaceX who are good at coding, right? I feel like most of aerospace engineering is just, you learn physics and then you just code.
You just code it.
So yeah, they take advantage of air drive.
Because a big thing, right, with the whole... So, okay. If anyone listening plays Kerbal Space Program, please put it in the comments below. Because I want to talk to you. And I think I have mentioned this before. And the reason I mentioned this is because if you have played Kerbal Space Program, or if you don't know what it is, it's basically a game where you can build rockets and fly rockets. Reason why we're talking about it on this episode. And what you were just talking about, why it's horizontal, is actually it is scientifically accurate because it is what happens. But more importantly, you can see this happen in a lot of these games. In any rocket game or in any physics simulation, basically, in any physics engine, you can kind of tell. Think about a planet and think about entering that planet. What would be easier if you simply drop straight down or if you aerobrake? Now, aerobrake, for those unknown with that term, is basically, you have some orbit and via the atmosphere, you're going slower. So you keep going in and in and in until you finally land. So the question that I'm asking is, would you rather go straight down or would you basically go closer and closer almost in a spiral? And the scientific answer is by far a spiral. Because going straight down will not only damage everything on your craft because of the speed, but you are also retrieving the most amount of aerodynamic pressure, right? As Parker was saying, it's all about air pressure. So if you're going straight down, you're getting the most possible amount, which no person would want to sit in that rocket going at that speed, going in that trajectory. So what you're always looking for is you're always looking to be horizontal with respect to the surface, and then you very carefully start to become more and more and more vertical. When you are almost like 2 to 3 seconds, maybe 4 seconds above the ground, that's when it's called a suicide burn. So a suicide burn is basically when they max out their thrust, so when they just run at constant thrust for X amount of time, and after that time, they will perfectly be at 0 meters per second vertical on the surface. So the point of a suicide burn, once again, just repeating it, is you're at some speed, let's say 10 meters per second in some direction, right? Because you could be tilted X, Y, Z, because remember, this is 3 dimensions here. So you could be tilted in any direction. The suicide burn, after just throttling your engine, you will basically, after continuing to burn is a technical term, you will become straight, vertical, and then you will be able to land on the ground. So by a suicide burn, you will have wiped out all of your speed and you will land on the ground. Now, this is also a very risky scenario, because if you miss, then you could explode, which is what happened actually on some of the Starship videos, if you see. So if you actually look at the very first Starship test flight, when it failed, because it failed, I believe, 3-4 times. So with the very first one, it was going so fast that it had completely miscalculated its suicide burn, and it was already it was like on a 30-degree angle when it was coming to hit the ground. So that had just exploded. So I think even the second one had miscalculated it, but then when they finally got it, you can see how this works. So looking at any rocket landing, and I'm talking about SpaceX, recovering, you can see how this works. You can see it very, very carefully moving from like a horizontal-ish position to an almost clear vertical position straight downwards. So it's a very beautiful sight to see if you guys haven't seen it. So definitely go look it up. Yeah.